Good morning, good afternoon, and good evening, wherever you are. Um, our first speaker this morning is Dr. John Townshend from the University of Maryland, and who I looked up to for the last 20 years in a number of ways, not only for his scientific contributions, but for his scientific leadership. So we tend to underestimate in science, that uh, somebody builds these instruments and we get the data, we do the science, but we don't really recognize, all the efforts that went into creating these programs. And to me, John epitomizes the building of these programs, not only in the country, but also on an international level. So I don't think I know anyone who is involved in as many international programs as John is. So while he's doing the research and being a dean at the university and finds the time to build these programs, he's truly amazing to me. And today, what I specifically asked him to do is to really reflect on his career, because he has such broad experience, not only in conducting the research, but also in creating the programs. And I think that's what that's the kind of view that you're going to get from him today. And take it away, John. I'm glad you found our experiment to be interesting and willing to join us.
Well, thank you very much for your more than kind words, and I assume you can hear me clearly, can you?
Yep.
Very good. It's a little difficult to try and summarize what has now been an increasingly long career. As I point out to my graduate students on a number of occasions, is that my hiking boots are considerably older than all of them. I think they're about 42 years old now, so I've been going a long time. And let me give a little retrospective, but also to make an initial comment that normally graduate students are rightly told is that it's hard work, intelligence, application, but also, there's chance as well that comes in. And as we go through, I've got a green exclamation mark where I think that chance and luck came in. But the trick about luck is that you need to recognize when it arrives and not ignore it. Needless to say, I'm going to talk primarily about work on land cover and the efforts that I've made to try, along with many other people, to try and get more objective information on land cover. Again, a little bit of context. I got my bachelor's in 1967, which is a very long time ago. I suppose I could have put a little exclamation mark by the fact that my department was a very early adopter of quantitative methods. Like many people of my generation, I took no master's degree. I stayed in the same department to do my PhD. And the number of courses I took in order to get my PhD was precisely zero. The British system is different. It was also very different because of the fact there was almost a complete absence of computing, if it's possible to think of that. There was no real computer at University College, which is a very good university, until 1967. I started off by working in fluvial geomorphology and was very fortunate that there was a major library just across the way from my office, which had lots of papers from the USGS, and that started my interest in fluvial geomorphology. I was also very lucky that I was able to spend 5 months in an expedition to Mato Grosso before all the deforestation actually started, and I was very lucky to have an advisor, Eric Brown, who made that possible. But then at the end of the PhD, I decided to get out of fluvial geomorphology. It needed more math than I had, or alternatively, I was going to be involved in very long, boring process studies. And I would advise all graduate students when you get to the end of your PhD, ask yourself, do you really want to carry on doing this for the rest of your life? I decided I didn't and wanted to move on to other things. So I started off my first teaching position was in Dar es Salaam in Tanzania, and that was when I was kind of the equivalent of an assistant professor, and that's when I really got interested in the significance of terrain and the ability of terrain to sustain human uses. I didn't stay there long and ended up going to the University of Reading, And I was again very fortunate that the person, one of the professors there, a guy called Ronnie Navigier, was an early adopter of remote sensing, though not digital remote sensing, and he had managed to get our Department of Defense, or the Ministry of Defense, to part with very large sums of money. I would say that the first years when I was at the University of Reading, I was pretty mediocre. I didn't do a tremendous amount of really worthwhile research. I was very fortunate that I had some very good graduate students, in particular Chris Justice. Again, one of the important things, as you move through your career, is you get good graduate students, because you need to be continuously revived. And I think that's one of the big disadvantages often of working in government research labs, is you don't have the graduate students to the same extent. But I was fortunate that I did lots and lots of fieldwork all over Europe and in North Africa and elsewhere. One of the big problems that we had in terms of getting going was that there was no high-performance computing. There was virtually no computing, and the cost of image processing was really prohibitive. Eventually, I got very frustrated and actually built myself a digital image processing system, which I think must have been the world's slowest ever. It took something like about 15 minutes to load a 512 by 512 image, but nevertheless, we started to get it in the business. At that time, the European Space Agency was not doing much, and frankly, the UK was doing even less. So what was the big breakthrough into real remote sensing? Well, again, there's a green exclamation mark. It was chance. Jim Tucker, who I suppose everybody here knows well from Goddard, happened to come across to the United Kingdom. I think it was some sort of scientific tourism, which he tends to specialise in. And because he met my student Chris Justice got a postdoc at Goddard. And then I happened to be on leave of absence at Clark University, and I visited Goddard, and for that matter also the Laboratory for Application of Remote Sensing at Purdue University. And I was then offered a postdoc at Goddard from 80 to 81. And that was just a fabulous place to work, especially then. That was the place to work in terms of global change of science and remote sensing. And I started doing some Landsat land cover work, but I'd still say that it was fairly mediocre. So I think a lesson to you is that if you want to take any lessons from this at all, you can be a bit of a late starter after you start your career, and you can still have a fair amount of success. You don't necessarily need to be successful at every single stage of your career. And families intrude and all sorts of things. Well, by the early 1980s, a lot of us were talking. We said, well, perhaps remote sensing's already finished. Now remote sensing's gone. The biggest project, this is outside of geological applications, was AgriStars, and that was just cancelled summarily in the early 1980s. Then virtually the only terrestrial remote sensing work was actually government labs. At the same time, a particular idiot in NOAA decided it'd be a very good thing to privatise Landsat, and so the cost went to more than $4,000 a seed. So we didn't even have any data which we could scarcely use. And when I look at the decline in sensors at the moment, we're perhaps meeting another period like that when we think, well, perhaps do we really have a future or not? I'm sure we do. So what happened next? I think there were really two main aspects of revitalization. One which was very important was Landsat 4, which led to the creation of science teams. But that was a close-run thing. Landsat 4 was due to be launched with the TM, and a very short time beforehand, NASA decided that there was a shortfall, a relatively minor shortfall of about $30 million. And our friends from DOD turned up at a key meeting and said they would find the 30 million. Had it not been for them, I don't believe there would have been a Landsat 4 and a TM program, and goodness knows what would have happened to us then. But then there was also, thanks in large part to in all sorts of different ways, to Jim Tucker, we began to look at the possibility of using the dear old AVHRR in order to observe the land at far broader scales than had ever been possible before. and we can talk about just how many contributions Jim made as and when. Then we received a ludicrous challenge by a person some of you may have heard of, Jimmy Webber, who was then at NASA headquarters, and he said, I'll give you, I think it was something like about $50,000 or $60,000, and I want you to give me a continental land cover map, you know, the first ever, and you've got 6 months to do it. And Jim and I were insane to have agreed, since he was at Goddard and I was back at Reading. And at that time, there were just no standardized products. But there was a polar projection GVI product being created by NOAA. This is really just for browsing for image quality. And so we had someone who was smart enough to do the programming to reproject it. We decided to composite to monthly images to get rid of all the damn clouds. And we realized the only way in which we were ever going to be able to deal with the information there was to use the vegetation index as something which normalized a lot of problems, and we would use that directly to classify and monitor what was there. And we did it in 6 months. It was very interesting talking to people about it and showing them the results. We're all used to seeing now the greening up of Africa, you know, as the intertropical convergence zone moves north and then comes south. People will look at the images and say, these are just artifacts. These are not real. Your pixels are too big. And in fact, Jim had to work very hard to convince science to accept the paper. And one of the reviewers was actually convinced that we were just some sort of swindlers, and that we were just showing things which were completely artificial, just because people had never seen images like that before. Well, you know, things were going very well in the UK for me, actually, at that particular time. And, you know, I was given a very large, major-funded research centre. It helped that some of my ex-students by that time were taking up leadership positions. Graduate students are so important for helping advisors rather than the other way around. And also, I think it helped that I'd taken various leadership roles in the UK and Europe. I think also what helped is that I've made big efforts to be an effective speaker. Some of the people saying now he's an effective speaker, I don't believe it, but I am a fairly effective speaker, and I practice hard, and so many students do themselves down by giving the most incredibly boring talks. And one thing I would recommend to you is get in front of a video camera and just see how boring you really are when you're giving presentations, and try and improve your presentations, because this will certainly help you in your careers. So then I was persuaded to come to the New World and came to join Maryland in 1989 as chair of geography. Sam Goward and Steve Principal were in the faculty, and Chris Justice was on the research faculty. It took some time to get things up and running. University of Maryland in those days were a really sleepy outpost. And when you change countries, as some of you have found out, and funding priorities change, you're challenged to get resources. But gradually we've built up the department. I think why Maryland has been so successful, in different ways, we've always been focused on what remote sensing gives us on a scientific basis, rather than being interested in remote sensing for remote sensing's sake. MODIS was huge for all of us, for the department and for us individually. We helped to justify the 250-meter bands. That was a really tough argument, which we very nearly lost. I also mistakenly did not apply for the team membership on the first round, and this is another lesson to learn, I guess, because we assumed if two people applied to do work from the same department, probably only one or two at most would get it. And then, of course, we found out that Miami had got 3 team memberships for the oceans, and so that was a lesson: is never worry about competing with other people in the same department. Rama asked me to just comment on this particular paper, which many people see as fairly seminal, which was really just a review paper, which was just to say, hey guys, land cover characterization is really important, and by the way, we know very little about it. And I think that was a shock, and the next speaker Steve Running always comments on this, that was a real eye-opener to him, because he assumed that we knew where the world's forests were. If you look at what's happened since the paper, you just see now that some of the things being proposed are now just normal. I mean, everybody recognizes that you have to adopt a multi-temporal approach. The value of MODIS for land cover characterization is clear to all. Atmospheric correction is the norm, though only recently for Landsat. Since then, we've actually started to look at land cover in a lot of different ways, and of course we now often look at continuous fields, and I can't see any mention of that within the paper at all. What's probably though true to say is that actually getting some accurate numbers, it took an awfully long time. And I would say that really, for example, forest cover change globally, that really was not established until the recent proceedings of the National Academy of Sciences papers by Hansen et al. Two in particular. One of the things the paper asked for is sensor integration, and I think that still remains the exception rather than the rule in virtually all aspects of remote sensing. So this was the paper by Matt Hansen, the second of those two articles. I think this is the first honest map or product describing percentage forest cover loss ever created. And it tells us all sorts of things which we kind of suspected, but were certainly not in the official statistics. So if you look at Canada, for example, you see all the changes occurring there, but of course the official Canadian statistics say nothing is happening, but they don't count forest cover loss due to burning as being forest loss. Of course, we see all the changes which we're very familiar with in South America, but there we also see the huge changes which take place in southeastern United States. And it was really relatively recently that the amount of turnover of forest cover was even appreciated. But you can see it's one of those biggest signals when you're looking at the globe. And I think the credit to that probably should go, even though it's well manifested on this, probably that should go to Sam Goward, who was and his co-workers who were interested in the carbon cycle and actually started to look at what was happening in large areas of southeastern United States. I was just amazed to see whole landscapes turning over in 20 years. So what I've always been doing, and Rama referred to this, is to be involved in defining the future. A lot of people tend to assume that things just happen because unknown people make decisions or everything's going to work out all right anyway. But what it seemed to me in the early 1990s was almost a complete lack of international national strategies associated with defining the needs of the terrestrial community, not only with reference to land cover, but the terrestrial community as a whole. So I got involved very much with the IGPP DIS, and the big thing which came out of that, and a lot of people responsible, not just me, was the 1 kilometre global aviator R project and the product which was created from that. And then also the global climate observing system, which has been reasonably successful, the global terrestrial observing system, which has been pretty much a damn failure, though there's some signs that it may come back. Then the CEOS, which is the Committee on Earth Observing Satellites, which I tried to be involved in a lot in order to influence people in space agencies. Then GOSSI Gold, which is concerned with forest cover, which has been very successful, I think, in really setting agendas for what we really need. And then various other activities, National Academy of Sciences committees and boards, NASA and NOAA committees. Why do you do this? Because otherwise you're leaving it to others to define what your future is going to be. It means what it also means, though, if you can actually persuade people what the future should be, it positions you extremely well then to take advantage of new opportunities. People in NASA, for example, often said, it's amazing how well Maryland at times manages to position itself so that when the AOs come out, you're ready. Well, it's because so many people here and elsewhere have helped set those agendas to which NASA then responds. But it only really works if you can work with others, and the most important thing is to let others take the credit. Take no credit for this at all. When we were doing the 1 kilometre aviator R project, CEOS, the Committee on Observing Satellites, we having defined what it was and persuaded various people to do it, CEOS suddenly declared it as their project. Some of my colleagues were really sad about that. I was absolutely delighted, because if CEOS took ownership, it increased the chance that it was going to be successful. Well, this is slightly out of place. All this is just to point out that the actual FAO figures really completely contradict those of the Hansen et al. Product, and if you refer back, you'll be able to see. Then another really important thing for me was getting involved with the ESIP Federation, who are holding their meeting as we speak. Somewhere in Wisconsin anyway. And this led also to setting up of the global land cover facility. Now, I started to try and build up linkages with computer science here at Maryland pretty early on. And we were successful in getting major funding from the NSF for high performance computing in the late 1990s. Fortunately, we were so ahead of the game that I think, quite honestly, looking back, it was a flop. Because even though our computer science department is very good, actually optimizing high-performance computing is no easy task, is it? No, everybody knows that has ever tried. And we were so early that it was really difficult to get the people with the right training to help us carry out the work. So you can't be too far ahead of the game is also a lesson to be learned. Well, the ESIP Federation was a great opportunity, and here's another little green exclamation mark. Relatively few people applied because it was so new and people didn't really know what it was about. And so when you see new opportunities, you should think, can I modify what I do so that it fulfills this particular opportunity? Because if not many people apply, it makes it a lot easier to be successful. And so we set up the global land cover facility, and the very long-standing relationship in the IT world through ESIP. I suppose one of the big things that we did, it just opened up the use of Landsat and showed how that it could be made much more usable than it was. This is a bit of an old biograph. We're well over a petabyte of downloads now, and we're still distributing 30,000, 40,000 Landsat scenes a month. But a lot of the reason why people still like coming to us is because we ensured that the data was all in a uniform form, and when you come to the site, it doesn't matter whether you're looking at Modis products, Landsat data, or whatever, everything is just arranged in a very, very similar way. So it's very easy for people to navigate around it. So where are we now? Well, I'm now Dean of the College of Behavioural and Social Sciences, which seems slightly strange since I'm only barely a social scientist anyway. I argue that since I look at changing land use in the world, that somehow justifies it, but people seem to be tolerant of the fact that I really came from a non-social science background. I'm still maintaining research programs, work using Landsat, also maintaining team membership of Modis for the BCF. I still have graduate students. Some of I note have nothing better to do this morning than to attend this particular workshop, since they should know what I'm doing, but perhaps they don't. But what I've also done is to, in the last few years, is to build up relationships with people in China. And some very good working relationships. We're just opening a joint center with Beijing Normal University, also working with various components of the Chinese Academy of Scientists. I'm going to Chengdu to the Mountain Institute this October to talk about them. There are just wonderful opportunities in China to work with people and frankly, to make a difference, hopefully, in the way in which they're developing their programs. And if you ever have the chance to go to China, I'm talking to the non-Chinese, always take up the opportunity, if only because the Chinese are, without doubt, the best hosts in the world, so you will be treated well. So this is just to show the outcome of some of the work which we're doing with measures, and so we produce these global products of surface reflectors with atmospheric correction of Landsat data. And I think that all being well, USGS will be making such corrected products available in the future. We've really got to be serious about terrestrial remote sensing. We've just got to forget about looking at the top of the atmosphere. We need surface properties. And this is just about to be published. This is the first Landsat, wall-to-wall Landsat product of forest cover the whole world. Also with the changes to the whole world as well. We're not putting yet to publish numbers because it's a challenge to make sure that we've got the errors well characterized, but we are well on the way. It's interesting that one of the subtitles of this, of course, is high performance computing. But I think we have to recognize that for many applications now, you don't need high performance, relatively speaking. You do for some tasks, for sure. But it really is within the grasp of everybody to be able to do a global characterization of the Earth using Landsat data. This is our puny little system, and we can do global atmospheric correction of a single image of the whole world in a week. So this we bought 3 or 4 years ago. We could do far better if we spent the same amount of money now. So things really are an awful lot easier than they were. So I was asked to say a few things about future challenges. Well, routine monitoring of land cover is really close. And I certainly will not now go into this area unless I really thought I'd had some great winning idea to improve land cover characterization. The thing to do is to try and get into those areas where the people aren't working, not to follow the pack. And I think that's why I managed to be reasonably successful in my land cover work, because nobody else was hardly doing any work on it at all. One of the big problems we've still got is reliable error estimation. I haven't seen any error estimation in even continental products, which I believe in. It's just a remarkably dull, boring, enormous job to do, and we've still not got our act together. I do see that the integration of radar and optical remote sensing, I still can't believe why it's so understudied and why people don't do that. There are newer technologies such as LiDARs coming on, but obviously we have a real dearth of missions to look at. One of the big areas, I think, must be the integration of the biophysical dimensions of global change and human dimensions. I think this is going to be essential. The biggest forcing factor of global change, are decisions made by human beings. It's got less and less to do with the biophysical world. It's what human beings are doing. And what that means is we've got to engage social scientists, not just mugging up on a little bit of social science. Economists, obviously, for a whole range of, to understand a whole range of decisions, understanding decision-making itself, and that's why we need to engage people from psychology. Governance is crucial, so we need to involve people from political science and sociology. There's issues like terrorism and global change, where you have real problems associated with global change. This often leads to state instability. And we need, obviously, improved modeling of human behavior, not just with standard agent-based models and this, but certainly trying to improve them. And there we do need high-performance computing for sure. So I've been saying this for years, but I still say as a community, we need to be better organized in demanding what we need. The terrestrial community remains very disorganized compared with the oceans and atmospheric community. Just some final words. A successful career in global change as science is increasingly one of successful collaborations. This started out as my story, and it finishes as ours. So, although it has its downsides, I do think that research universities is just a terrific place to be. As I say, graduate students make a huge difference. One thing which people may not mention is that I think it's very important that you have high ethical standards. One thing just on a purely practical basis, if people can't trust you, they're not likely to be collaborating with you. But in any event, I think you should always treat everyone in your organization with respect, whatever their role, and have a zero tolerance for intolerance. And finally, if you don't find research fun, then go and try something else. You'll be better paid, and you'll enjoy yourself more. Research has to be fun. So thank you very much for your attention. Thank you.
Thank you, John. Thank you for that perspective. And we'll open the forum for questions. Um, Anybody around the table? Yeah, go ahead.
Hi, John. I did have a kind of a technical question about what your criteria were for defining the forest loss. When you're talking about your forest loss maps, how are you defining what constitutes a lost forest?
Yeah, well, we're taking two basic approaches. The one, which is the simple one, is just taking the common boundaries for forests, and we're taking 30% and 60% open forest or open woodland and closed forest. In part because a lot of people are very interested in those sorts of numbers. But we're also developing a much more probabilistic approach, which is to understand the errors associated with forest cover at any particular date, and then assessing whether or not forest cover change has taken place on a probabilistic basis, understanding the uncertainty of both of those dates. And that's obviously far more in keeping with vegetation continuous fields. Classification, crude classification, always has enormous problems, even though people are always very interested in those particular numbers.
Okay, thank you.
Sure.
I had a question, John. The map of the global map of forest cover, Hansen et al. 2000 is a very
2009, I think.
Very exciting, and I'm wondering about what the impact of cloud cover was on those estimates. I really appreciated your comment about our inability to have highly accurate error estimations, but I'm thinking about sort of broad trends, since equatorial Africa is one of the cloudy places. Do you think we're missing some of that, or a substantial part of it, because of the cloud cover?
I think in the far west, and the thing I put up there was Matt Hansen's. I'm not taking a particular credit for that at all, of course. But the way in which he carries out the work, which essentially is to use MODIS data to understand and then look at the relationship of the MODIS data to Landsat data. So you know what the MODIS signal means in terms of loss. Because MODIS is not perfect at getting rid of all the cloud, compositing, and if you pick the right characteristics from the multi-temporal signal, a lot of those effects of cloud are eliminated, and then of course you're picking your Landsat data in order to have cloud-free scenes as well. I think that the future certainly must lie in really two things. Firstly, the sort of work that David Roy's doing in his WELD product, which essentially is to do almost pixel by pixel examination to pick the best Landsat pixel in a given time period, is clearly one of the ways to go to minimize the effect of cloud. The other thing is, though, is we need daily Landsat data. It's obvious. Here we're waiting for the next Landsat, which will give us the same boring frequency that we had before. And what we really need is daily images, and as people have said for a while, we need to MODISize Landsat. We need to have all the compositing and all the various things which we did with MODIS, but at Landsat resolution. It's a great lack of vision of the of space ages in the terrestrial community. That after all these years, we're still waiting for such an inadequate frequency of imaging, which will be every 16 days, or if we combine with Sentinel, then it would be every 8 days. It's ridiculous. A long answer.
So I have a question from the chat room. This is from Hamad Gilani. He is asking that you talked about a number of global initiatives, and he is wondering if there is any kind of a synergy among all those global initiatives that you're working on?
Well, I mean, some of those are what I used to work on. You know, you move into areas, you move out of areas. There is synergy, and people in those groups do work together. One of them that I didn't mention on there, of course, is the group on Earth observations, which I've been involved in on and off. And these people do try to work with each other. Often the constituencies are different, and so that's why you often need different groups. So if you're trying to work within the framework of meteorological agencies, who often provide a lot of the important climate data, you have to work through the Global Climate Observing System, which is part of the World Meteorological Organization, and the governing board of the World Meteorological Organization are the heads of, very largely, the heads of Met offices. If you're interested in trying to influence the space agencies, then CEOS provides a very good forum, because basically to be a member of CEOS means that you have to be responsible for a space agency which puts Earth-observing satellites. So it tends to be complicated, but I assure you that compared with many other activities in climate and oceans, we're relatively simple. You just need a lot of different structures to maintain these things internationally and to persuade people to move forward in the way you think is important.
Thank you. Any other questions that are on the table? So I have another question and comment from Ranga Maineni. So he's talking about Hansen's paper that came out in PNAS. So he was wondering about the issue with the Finnish forest. What happened there? It seems there was some kind of a...
Yeah, you asked Matt that, and I think that there are issues with that paper, just as there are with any paper. But what I would say is it's the first, that illustration, and I wouldn't go into too much detail in any particular part, but it's the first illustration of what's happened to forest cover change which bears any resemblance to the truth whatsoever.
So I have a question.
Can I say, there is a comment also about forest use. I think this is a real issue, that we always must be clear about forest use and forest cover. And I even proposed, but I got nowhere with it, is that when you're interested in cover, don't ever use the term forest at all, because foresters always think about forests as being land use. We tend to say forest cover, but they still don't really understand it that way. And so foresters everywhere think of forests as being used. And that's the reason why Canada always reports to the Forest Resource Assessment that they have exactly the same amount of forest cover, and there never is any change, because they're just regarded as a land use. So the fact a lot is destroyed to them is neither here nor there. If you're interested in the carbon cycle, it is rather relevant.
So I have a question. So land cover research seems to be one of those areas where you could really deploy the social networking tools. So is there any initiative along those lines to use the web and all the people that have cameras and all sorts of sensors that they're carrying around?
Yeah, I mean, there have been some crowdsourcing efforts and people taking, pictures of latitude and longitude intersections of various places. I'm not personally, I think if a group of people talking to each other, right, directly, then perhaps real social networking, it could be helpful. But just taking random pictures around the world, it depends so much how you take the darn picture. and I'm not sure it actually produces particularly reliable information. But I think it's a good point, having perhaps limited number of people exchanging views and people being able, perhaps in real time, to walk around, and so people can actually see what you're talking about. Could be very helpful. There's a question here asking, what do you mean by routine monitoring of land cover? I mean that it just becomes something which you could just give it to an agency. I mean, it starts, some of the basic land cover monitoring just falls outside of the framework of what people probably in universities should be doing. It's noticeable that it didn't quite work out, but that in China, the job of generating a global land cover product at Landsat resolutions was given to the the National Geomatic Center for China. I think I got that. Perhaps Meng Shu, you could type something in the chat if I got that wrong.
I wanted to bring up the issue of the optical and radar remote sensing integration for land use across large areas. I have a little experience with that, and one of the things that's really struck me, even after 2 years of working on it, is that the radar folks, because of the radar sensors are inherently so different than the optical ones, the pre-processing is entirely different, and the kind of mindset or the models that they're coming with are very different, and so it is quite a challenge. And I'd be interested in hearing about what could be done to address that at sort of an earlier stage, before those models have sort of been ingrained.
Yeah, I mean, it is just amazing that the two communities still don't seem to manage to talk to each other. One model I've thought about, which I thought perhaps had the prospect of working, and it goes back to a previous topic, will be, since we are pretty ignorant at times about what's happening in Central Africa because of the very high cloud amount, that have a joint project between people who specialize in optical remote sensing, radar remote sensing, try and create the best forest cover product and forest cover change product which is possible to create. And actually getting people working together on the same activity would be a good idea. It also seems to me that in terms of acquisition strategies, the space agency could be and should be getting together rather more, because it would seem to be a no-brainer, is that one of the areas where you need to decide to acquire radar data is in those places where we know we have very high cloud cover. But so far as I know, nobody's ever really carried out a systematic acquisition strategy in that way, even though that recommendation has been made a number of times. Xiaopeng Song asked a question which was answered in part by a fellow student of his, Hao Tang. He was asking whether we're expecting any LiDAR missions at NASA or ESA or any other agencies around the world. I mean, the fact that NASA has not put up a LiDAR is just an absolute disgrace. I mean, it's an absolute disgrace. That, I mean, they've been talking and on about it for ages. There was a really excellent opportunity to put a LiDAR out on space station. Instead, we got some mission which is supposed to improve our ability to track hurricanes, which I thought we could do pretty well anyway. Whereas when it comes to the vertical structure of vegetation, we know virtually nothing. So, yet another dumb decision, as far as I'm concerned, by our masters at NASA. And the loss of BCL was bad, and Destiny, the fiasco that was there. So, reality will come, and ISAT 2 will be along, yeah, but we really do want, if at all possible, LiDARs which are designed for specifically for looking at vegetation and having appropriate acquisition strategies to do it properly. So I'm a little passionate still about some of these things. And of course, I wasn't talking about anybody at your fine institution, Rama. Not at all.
Yeah. So this land cover research has evolved over the past 20 years, starting with 8 kilometers and to 1 kilometer to 500 meters to now 300 meters. So where do you think that we're going to end up in the next 5 years?
Well, I know what we should be doing. Whether we will do it or not, of course, it's a different matter. It's obvious we should be thinking about doing systematic mapping and monitoring, not necessarily wall to wall, but globally in selected areas. At 5 meter and finer resolutions. I mean, people talk a lot about RED, for example, reduced emissions through deforestation and degradation. But quite honestly, you can do a little bit. You can do some things with Landsat data associated with RED. But when it comes down to it, you really need much finer resolution if you're really concerned with monitoring what the individual person may be doing within the forest area. I know certainly the people who are developing an operational system in Mexico. They are not looking to 30-meter data. They're looking for 5-meter data. And really, what we should be having is routine 5-meter data. So we should be having the sort of acquisition strategy which currently we have for Landsat. We should be having that for 5-meter data, which is to ensure a couple of looks for every place on Earth, preferably cloud-free, on a yearly basis. Now, sometimes people sort of say, "Why do you keep asking for the moon?" I'm not asking for the moon. I'm just sort of saying, can we just have a bit of vision? So think about what happened in the late 1960s when, in answer to various complaints about the Earth science community, it was agreed that there could be a civilian Earth-observing satellite, right? Called Earth at first, and then became Landsat, which of course was launched in 1972. So in the late 1960s, and some people had the vision to say, why don't we put something up which will look at the Earth, admittedly often looking at the cloud, but will look at the Earth, basically every 16 or so days, I think it was 18 days in those days, at 80-meter resolution. Can you see what an unbelievable piece of visionary thought that was in the late 1960s to say we're going to have digital data of the whole Earth? And since then, we have the tremendous expansion associated with EOS. And of course, most of what happened in EOS was a result of thinking in the 80s under Shelby Tilford. And then, since then, frankly, in large part, we seem to have gone to sleep. The rate of advance has slowed down desperately. And I think everybody's got to be, far more demanding of what space agencies do than we currently are. We've got to be just far more critical and drive them forward to do better things. And that's not just NASA. That's what's happening in China with the ludicrous duplication. Every damn ministry wants its own optical satellite. There'll soon be more Chinese optical satellites than any of the sort in the world. So there's a tremendously wasteful duplication going on there. We really have no rational plans for developing what we need as an operational observing system at all, despite the best efforts of organisations like GEO. Sorry, I'm sounding off.
Yeah. So, yeah, there are a few more questions. Probably you see them on the chat. Um, so,
Yeah, I think
Ranga,
that's
yeah.
a question from one of my students at Dansh's Song, asking examples of how social sciences are expected to involve in the current terms of remote sensing. I think it's the issue which Dan Shah raises is that it's really tough to get people with knowledge both of the social sciences and also, with knowledge of the earth sciences. I think what is really needed here is for people, faculty members, to engage with people in the social sciences, and then have people who are ready then who understand why they're important, and then to get agreements to jointly co-advise people who want to look at that integration, because you've got to have both sets of people involved. One person that Dan Shah is very well aware of is a colleague, Xiaopeng Song, another one of my students, but he's a real exception in as much as he got a degree in basically GIS, remote sensing, and a degree in economics. He got a double degree, but the number of people like that are very limited. And so, if we're going to get collaborations, we can't just wait till people keep getting double degrees of that sort. We've got to find other mechanisms to get people engaged. And I think it's up to us, as those people more senior, to reach out to people in the social sciences and to get them involved. I think it's absolutely crucial. One of the things I'm doing, as dean, is to build up the human dimensions of global change, to get social scientists directly engaged. And perhaps remote sensing will be important to them, perhaps it won't. Perhaps it'll be the model outputs which are important. But we've got to get those people defining the agendas. What we can't have is having, as is typically the case, where we have a very large biophysical project, and then they invite the odd social scientists along to help. That is not the way to make progress. The social scientists themselves have to define what the agenda is that interests them, and it's only then I think that we'll make proper progress.
All right, happy with you.
You don't want to ask Ranga's question?
Yeah, there is one comment from Ranga about forest cover changes over the past 40 years. What your thoughts are on?
Can I get to that one? I can actually read that one. Mungshu Lee has, from Urumqi, has been trying to ask questions. This question is whether there's any specific strategic plan or program from NASA on supporting global land cover monitoring research through international collaboration. I mean, NASA does work internationally and is working with various groups. But I do not know of any attempts at the moment to come up with a really coherent strategy to involve all the main players. I know some of the activities which are going on within GEO, but frankly, that they leave a lot to be desired. There's certain aspects that are going very well, and one of those I would say is agricultural monitoring, which is showing a lot of improvements over where we were recently. And so, from my dear friend Ranga Maineni, was asking, has forest cover increased or decreased? And for sure, it is decreased. But you raised the very valid point: is you do have the abandonment of land, and you do have forests tend to come back. But overall, it is downhill. It's also worth noting that some of the people who look at modelling of economic behaviour and forests are sort of people at the Global Change, the Joint Global Change Research Institute here at Maryland under Tony Janatos. And essentially, if you try to model to see what's going to happen in the future, if you don't put a price on forests, it doesn't matter what assumptions you make, they're pretty well all gone within 40 years. Unless we can somehow start to value forests and it's worthwhile people not cutting them down, there isn't going to be any forest, or no substantial forest left at all.
Okay, with that, we have to get ready for Steve Running's presentation, John. So thank you so much for your time.
Did you do, and I'm sure Steve will be highly entertaining as he always is. So my good wishes to him, and thank you for this experience, and thank you for your initiative in doing this. It's very much appreciated.
Thank you.
Okay.